Okay, this is the last thing that you're going to be studying in curves, and it's in the definitions, and it's just for calculating the area. And a lot of times you will have a property description, and when you're doing your calculations, it's just easier to go from this point to that point instead of entering curve information. So when you calculate the area for the tract, then this area is left out. So I need to teach you how to calculate for the the sector area and the segment area. What's a sector? A sector is a slice of a circle, and it includes all of the arc area and all of that triangle there. So that's a sector, and a segment is the area of that sector lying outside of the long chord. So it's this area here. Now, if you are staking a pipeline, a big expensive pipeline, and somehow manage not to stake it on the curve, but stake it here from point to point in a straight line, then this area right here is the area you'll probably have to pay for. So you want to be sure you don't do that. That's the segment area. This whole area is the sector. So you got two ways of figuring the area for a sector. You can do it in radians, and again, a radian is nothing more than the arc length divided by the angle, and the formula for a sector is r squared times the delta angle over 2. That's it. That's real simple. So if you've got a calculator with a radian function, use it. It makes life much easier. But that's for the sector, the whole thing. Now, if you're calculating the area of the sector and you want to use degrees, it's a different formula. It's basically how you figure the radian, pi r. Gee, that sounds like the area of a circle, times the delta angle over 360. So all you're doing is figuring out the percentage of the area of a circle. Not that hard to do. Now, what about the segment, this area here? Well, that's a little bit more complicated. It's the radius squared over 2 times pi divided by 180. That's the inverse of a radian, by the way, times the delta angle in degrees, minus, and that's there, minus the sine of delta, so basically radius squared over 2 times the inverse of a radian, which is pi over 180 times the delta angle in degrees, minus the sine of the delta angle in degrees. So in this case, with a 1,200 foot radius, 80 degree central angle, we come up with an area of the sector of 1,005,309.649 square feet, and then the area of the segment comes out to be 296,248 feet. So that's all you need to know now. Have a good Thanksgiving. If possible, don't eat too much turkey and fall asleep in front of the television like I'm going to. And if you have trouble with the homework, you know how to reach me. Have a good Thanksgiving, and I will see you and talk to you before the final exam. So you all take care and have a good holiday.